perhaps one of the biggest idea in statistics is the idea that we don't necessarily need to know what everyone is thinking in order to know what everyone is thinking. And it has to do with the idea of taking a sample of people and using that sample to make a really good prediction about what everyone is thinking. So in this case here, what we have is, say Fox News had a random sample of 980 voters, and what they find is 539 people of that support the death penalty. So what we're going to do is we're going to create what we call a 95% confidence interval to give us an idea over what everyone is thinking. So for instance, what you would do is you would define the sample proportion. If you were to take 539 and go ahead and divide by 980, what you have is you'd have 55% of people actually supporting the death penalty. And that's kind of our guess, but what we do is we kind of hedge our bet with what we call a margin of error. So it might end up being, for instance, 55% plus or minus 3%, or it could be another number, but let's say it was 3%. So what that would tell us is that that range would range from a low of 52% up to a range of 58%. So we might, in this case, believe, hey, we think it's around 55%, but we're 95% confident it's somewhere in this range, somewhere between 52 and 58. It might be 57 or 54.2 or something along those lines. So we're not sure exactly, but in order for us to know exactly, we'd have to actually get all voters, and to do that it would take a lot more than 980 voters. It would take actually millions and millions of people, which would be very unfeasible. So instead what we do is we have a small sample of people, in this case 980, and it helps us get a general idea over what everyone is thinking here. So for this method to work, we actually need to do three things: check conditions, actually calculate it, and it will vary depending on how confident we are and also our sample size. And then finally, once we come up with the numbers, we're actually going to state what it means in words in this context here. Alright, so let's go ahead and get started here. So the first thing is there's actually four conditions for completing what we call a 1 proportion Z interval. The first one is what we would call plausible independence. So I'm going to go ahead and write that over there. So in this case here, is it plausible to think that what one person thinks about the death penalty does not affect what others think? Well, maybe if it was just your friends or family, that wouldn't be the case here, but we're talking about 980 randomly selected people throughout the country, so there shouldn't be any effect whatsoever. So what you'd write is you write independent, what one person thinks about the death penalty does not affect another. And I'm going to go ahead and abbreviate death penalty with capital D, capital P. Alright, that's one condition right there. Is this a random or is this a representative sample? And in this case, we would say that's a random sample because it says so up here. So the second one would be that it is a random sample because it's stated. Alright, next up, is our sample size less than 10% of the population? Well, is it fair to say that if you were to multiply this by 10, which would be 9,800, are there more than 9,800 voters out there? Well, definitely whatsoever. So go ahead and we'd say, hey, 980 is less than 10% of all voters. And then our final one is we're going to go ahead and figure out successes and failures. So the number of successes is actually already told to us in the question itself. We know 539 people said that they go ahead and support the death penalty, and that's obviously greater than 10. And for failure, if you were to go ahead and take the total number of people, which is 980, and subtract the 539 people, you would wind up with 441, and obviously that is greater than 10 at all. So we've met all the conditions here, so now we can go ahead and actually calculate what the confidence interval is. So how do we do that? So there's a basic formula over here, and you can see it here in the box. We take our sample proportion, and if we recall, our sample proportion was 539 divided by 980, and that ended up being 55%. So I'm going to go ahead and put 55% over here, and then we're going to go plus or minus, and then we have what's called a Z star. And the Z star for 95% ends up being 1.96, and I'll show you why it is 1.96. If you were to go ahead here in terms of 95% confidence, that means we're looking at the middle 95% of all values here. And to actually figure out what that is, we're used to thinking that as 2 standard deviations, and it's close to that. It's actually 1.96, and here's why. If it's a normal curve, it's perfectly symmetric, which means we have 2.5% over here. And so if we were to figure out the z-score for each of these spots right here, what we're going to do is we're going to do inverse norm. And in the case over here on the left, it would be 0.025 because it's only 2.5%. To do this one, it'll be inverse norm instead of 0.975. So if you were to go ahead right now in your calculator and do inverse norm of both of these values here, what you're going to wind up with is 1.96. And so anytime you're doing a 95% confidence interval, that's always the z star. That's z star right here value that we use. If we were 90% confident, it's going to end up being 1.645, and these are the most common ones you'll see on questions here. So you can go ahead and write these numbers down, and they'll show up over and over again. The other thing is, you'll notice over here, we're using p hat and q hat in our formula here, and here's why. That's what we call the standard error, SE. And the reason why we do that is, if we were to do the standard deviation, that would be PQ over N. And what that means is P is the proportion of all people, and we don't know that. That's in fact part of the whole problem here, is we don't know what everyone's thinking. So we can't use standard deviation. So what we have to do is have a backup plan, which is what we call standard error. And so in this case, what we're going to do is it's going to be 0.55 times 0.45, because that would be Q hat, and then we divide by 980. So what you want to now do is, on your calculator, actually take 1.96, multiply by this square root, and when you do that, you're going to get a number. So go ahead and try that right now, and what it should be when you're all done, it should wind up being about 0.031. So this number right here is what we call the margin of error. Then all you have to do is go ahead and subtract 0.031 from this and go ahead and add it. When you're done doing that, you should wind up with a low value of 0.519 and a high value of 0.581. So once again, the 55% is what happened in the survey, but we kind of hedge our bets a little bit because we only had 980 people. We didn't have everyone. Also, we're 95% confident. We're not 100% confident because we haven't asked everybody in the whole country what they think. So we now have a range of values here, and it's just as likely to be closer to 51.9% as it is to be on the high end or in the middle. Any of the numbers in there would make total sense. And so the final piece is, now that you've done this, is you need to go ahead and write this in words. So that's what we call interpreting your confidence interval in context. So here's how that will look. We say we are, how confident are we? Well, we're 95% confident, so we say we are 95% confident that 51.9% to 58.1% of all voters support the death penalty. So even though we haven't actually gone ahead and interviewed every single voter in the country, and there would be millions of them, by sampling 980 and actually running the numbers here for our confidence interval, we're really pretty confident here that it's somewhere in this range. And that's a lot of information there, and it certainly saves us a lot of time and energy. Now, there's obviously no guarantee that it's in this range because we're only 95% confident of that, but certainly it gives us something to think about in terms of what that actual number is. So that's typically what we do in every single problem. Occasionally you're asked for one other thing, and this is pretty, it's not commonplace, but maybe sometimes. But explain what does 95% confidence mean in this context. And so basically what it means is this. If you were to go ahead and take lots of samples, so not just 980 people one time, but do it again and do it again and keep getting 980 people, 95% of the confidence intervals that you actually ended up creating would contain the true population proportion of people who support the death penalty. So once again, we're confident that it's somewhere in this range. However, this may be one of the 95% of the confidence intervals that actually has it in the true population proportion, or maybe it's part of the 5% that doesn't. But the idea here is, once again, it gives us a really good idea of what's really going on in the entire country without actually having to ask everybody.